Emma, Matthias, Thomas, and Clive, whenever you're ready, you can start.
Okay, so we are the Electric Zombies, and this is our project on laptop price prediction. We made this project because every year there are 42 million laptops sold in the United States alone, and $102 billion worth of laptops sold globally as of 2021. Let's see, what is this project about? This project was designed to predict the price of a laptop based on different features such as size, GPU, CPU, memory space, operating system, and company. This product was meant to make buying a laptop a quick and easy process that will fit the needs of the consumer. The ultimate goal of this, what is the ultimate goal? The ultimate goal of this product is to predict laptop prices so that the consumer that uses it can find the best match based on their own preferences. What is our data set? Our data set listed out different computer products from various companies based on their features, such as CPU and screen length. Classification or regression. This project is a regression model because it is predicting laptop price, which is a continuous and not discrete value. What is our minimum viable product? It is a website that will take user preferences for laptops. The website will then use those variables to find laptop prices within the certain price range. Why does this matter? If someone is planning to buy a laptop in the near future, this can be a simple and useful tool to get an estimated price for the laptop. Why data cleansing? Clean data increases productivity, accuracy, and ensures quality results. Removing unwanted columns. Sometimes data frames can have columns that have little to no use for the final product that we were making, so we need to remove them. Dealing with null values is removing data that has no value, aka nulls. A null represents an unknown or missing value that might affect the quality of operations of processing, classification, or any other data analysis. Transforming data. A few columns in our data did require transformations such as the RAM, weight, CPU, etc. For example, in the RAM column, we changed 8 gigabytes to 8 and 16 gigabytes to 16, changing a categorical data into a numerical one. Encoding data. Our data contained both numerical and categorical data, but the machine learning model we used was unable to comprehend the categorical data. This made it necessary for us to encode our data, transforming categorical data into numerical zeros and ones that the machine learning model could understand. Here's Mathias.
All right, so EDA. Why is EDA required? EDA involves using statistics and visualizations to analyze and identify trends in data sets. It's essential for any business. Okay, is there any relation between laptop price and operating systems? So what we observe from the plot is that laptops with Mac OS have a greater median cost compared to any other laptops, and laptops with Android operating systems are less costly compared to other operating systems. Companies, is there any relation between laptop price and the companies that made them? What we observe from the plot is that the company with the highest average price for laptops is Razer with 3,346.1 euros, and the company with the lowest average price for laptops is Vero with 217.4 euros. For the CPU, is there any relation between laptop price and CPU? What we observe from the plot is that laptops with Intel Core i7 have a greater median cost compared to any other laptops, and that laptops with Intel Other are less costly compared to other CPUs. For the GPU, is there any relation between laptop price and GPU? What we observe from the plot is that laptops with NVIDIA Quadro/GTX have a greater median cost compared to any other laptops, and laptops with ARM to AMD are less costly compared to other GPUs. And finally, the RAM. Is there any relation between laptop price and the RAM of the computer? What we observed is that laptops with the RAM of 32 have the highest median price at 3,147 euros, and laptops with the RAM of 2 have the lowest median price at 234 euros. And I'm going to pass it on to Thomas.
So machine learning pipeline is a multi-step process which we use to prepare our data and make it interpretable. Our first step was data cleansing and feature engineering. We cleaned the data and removed unnecessary information and replaced missing data. The second step was train test split. We split up our data so that we can train 80% of the data and test 20% of the data. In imputation and encoding, instead of deleting large amounts of information, we clean our data by replacing missing categorical data with the mode or most commonly occurring result of the column. For numerical nodes, we replaced the missing points with the mean or average of the data. The fourth step was model building. We tried out several models, but we picked out 3 to showcase, which are linear regression, random forest, and XGBoost. The final step was fine-tuning through grid search CV. We fine-tuned our models using the grid search CV function to get us the best possible parameter values, which gave us the highest possible correlation. And I'll pass it to Clive.
So for our models, the first model we tried out is linear regression. And linear regression is a type of machine learning model that uses the correlation of an X variable and tries to determine the dependent Y variable. Using given data points, a straight line is created best fitted to predict a trend on how the data will continue in further data points. So for the linear regression model, we achieved an R-square score of 0.744, a RMSE of 388.19, and a MAPE of 23.72%. Moving on to the second model we tried out is the random forest regression, and it uses a technique called bagging. And this method uses a multitude of decision trees to release a prediction for the output. And random forest models contain several working parts that make the way this model computes data uniquely. And for the random forest model, we achieved an R-square score of 0.7795, a RMSE of 350.26, and a MAPE of 17.09%. And finally, the third model we tried out is XGBoost regression. And in XGBoost, a loss function in its optimization and use will be dependent on the type of problem being solved. So decision trees are used as the weak learner in the gradient boosting process. And an additive model adds weak learners to minimize the loss function, allowing number trees to be added one at a time, and existing trees in the model are not changed. And for the random forest model, in the XGBoost model, we achieved an R-square score of 0.7838, a RMSE of 330.3, and an MAPE of 17.36%. And so that means that out of all of the machine learning models we have tried out, XGBoost gave the most accurate results, and therefore XGBoost is currently the algorithm in use to predict the price of laptops.
Okay. Coming to the last section, we have a form where user can enter the information of what type of laptop they want to choose. So I'll just give a sample example. For example, if you want to choose Microsoft company and a gaming laptop with screen length of 16 inches and some 4K resolution, and with Intel iCore 7 and some RAM of 32, and with a memory of 1 GB, like 1 GB, and with NVIDIA graphics and all, and with Windows 10 system. And when I click on predict, this machine learning model will take this input and will give out the price prediction for how much this, like how much a laptop going to cost with all these specifications. Okay, so it will take some time to.
I have a quick question.
Yeah.
So you put all these the variables in to do a prediction. Have you ever like compared it to actually what's out on the web? I guess source or whatnot.
So we haven't compared it to the actual prices because I think the data set we have is already scraped from the web. It's almost like the similar data set, but we never actually compared the inputs we are giving because there are some unrealistic things that are happening. So for example, I can choose company as Apple, and I can give a Windows 10 system as a
True.
Yeah, it doesn't happen in real life, but it's kind of the thing. Like I can give screen inch as 1 instead of 14 or something, but they cannot be a laptop with just 1. So we are just limited by a few things because of the data set we have and all the things. But we can further refine it.
I also think this is challenging, given that this is really challenging. That means when you're training the model, you would have to train the model literally almost every week or every month because hardware depreciates so fast nowadays that it's just like you do a prediction today, the price is like so much lower than tomorrow type of thing.
Yes, that's true. Like the older versions might be having some less cost maybe in the future, like maybe in 3 months or 4 months. And the one more thing is we are not having any new releases. All these laptops, all the data we have is past maybe 1 or 1.5 year back data. So we doesn't have any new releases that happened between this 1.5 year. We doesn't have that.
Well, it's a good data set to really, I mean, your team's analysis, just going through that is just a good data set to just like exercise that, you know, just analyzing all that. The only challenge is the time component of depreciation.
Yeah, and one more thing is like we need to filter out when you select company as Apple, you need to filter out all other options according to Apple. That is one of the challenging things. So that is it. Like I want to shout out to my team, like Emma, Clive, Thomas, and Mathias, Serenity, and Dania. So Serenity and Dania unfortunately was not in this meeting because they are unable to attend this meeting on this day. So that is it for our presentation.